Hi everybody, this is Tim Urdan, author of Statistics in Plain English, and in this video I'm going to demonstrate how to conduct a Mann-Whitney U test using SPSS. So Mann-Whitney U test is a non-parametric test, sort of comparable to a independent t-test, and it's really appropriate for use when your dependent variable is not necessarily forming a normal distribution. So if you have skewed data, for example, this is a good alternative to a t-test. And what we're going to do is we're going to analyze this variable, which is self-efficacy. This is from a collection, a data set that is from high school students, and I measured their self-efficacy, which is their confidence in their abilities to succeed in their English class and to do the work well. And a funny thing about American students in general is that their self-efficacy tends to be quite high, maybe a little bit overly optimistic for many students. And so the distribution can often be pretty skewed. So on a 5-point scale, which we used for this survey, scale from 1 to 5, it's pretty common to get a mean of over 4, which would be a negatively skewed distribution, or could be. So this would be a good variable to maybe do a non-parametric test on. So I'm going to compare boys and girls in their self-efficacy. So if you open up Analyze and you go to non-parametric tests, you'll see it doesn't give you the names of the tests that are in the textbook, like, Wilcoxon-signed rank or Mann-Whitney U. It asks for the number of samples. So you can do a one-sample test, independent samples tests, or related samples. In this one, we're going to do independent samples. And up here, if you hit objective, you can say automatically compare the distributions across groups. And if you look at the description, you'll see it'll either do a Mann-Whitney U test if you've got 2 samples, or it'll do the Kruskal-Wallis one-way ANOVA if you have K samples, K meaning an undefined number. So if you have like 3 samples or 4 samples, then it'll automatically run a Kruskal-Wallis for you. So we are going to select the fields. We'll do self-efficacy as our test field or our dependent variable, and gender as the groups. Now, SPSS is going to see gender only has 2 categories, so it'll automatically do a Mann-Whitney U. And then if I run it, here's what I get. The null hypothesis is that the distribution of self-efficacy is the same across categories of gender. And here's the test that it ran. Here's the significance of the test, and the decision is to retain the null hypothesis. So the Mann-Whitney U statistic is here. And remember, the Mann-Whitney U observed U needs to be smaller than the critical U to be statistically significant. We haven't looked up the critical U because we don't need to. SPSS will just run it for us. But this is a pretty large observed U, and that's not likely to be below the critical U value. And here is our p-value down here. Now SPSS gives a bunch of other output, which is pretty interesting to look at. The frequency of the scores in the 2 groups, and as you can see, it looks like it is negatively skewed. Most of the values are up here, up at the highest levels. So remember, this is a 1 to 4 scale. So this top bar, these top bars here, are students who answered 5 on the self-efficacy questions. And you can see that the mean rank, the average rank, is a bit higher for boys than it is for girls. That is common, where boys will be a little bit more confident in their abilities than girls, even if they're not performing better. And in this case, girls actually have the higher grades in English, but boys have the higher confidence. And it gives you the sample sizes for each group as well. If you go down here, you can see the distribution of scores. You'll see mostly 4 and 5, and then it tails off over at the lower levels. So that looks pretty skewed. Categorical field information by gender, just really telling you how many there are in each gender. And you can see in these statistics, we have an N here of 1,008, and we have an N here of 808. So we have 1,008 students that completed the self-efficacy scale, but we only had gender information for 808 students. And between the two, how many students did we have self-efficacy information on and gender? You can see that our total sample was 325. So there was some missing data on each of these variables. So that is what you get from a Mann-Whitney U test. Pretty straightforward in SPSS, pretty easy to interpret, and that's all you need to know right here is whether it was significant, and in this case it was not. So no differences between genders in self-efficacy according to the Mann-Whitney U test.